Hey, well, good afternoon, good morning, whatever time you're working on this class. We are going to get started with the Algebra 2 semester exam review for Unit 4. Just as a pre-warning to you all here, this is going to be one of our lengthier videos. This is a unit that covers a lot of topics that are going to be tested. I just want to make sure that you guys are prepared for the most part. Again, just a reminder, your exam will be December 8th. You'll have an hour and a half to do 21 multiple choice questions and 2 free response. Let's go ahead and get started. So this first question is asking you to solve the equation with the quadratic formula. So we've used the quadratic formula in the past. You'll recall that we have some A, B, and C value, where A is equal to 1, B here would be equal to 4. You need to be very careful with C, as it is not 45. It is a negative 45. Okay? And we're essentially solving for X, which is the solution. It is the x-intercepts. Okay? The roots, those are the three things that you might hear called. Okay? I'll say that again. It's the solution, or the x-intercept, or the roots. To solve for this, you would take x equals negative b plus or minus the square root of b squared minus 4ac, all of this over 2a. Okay, and what we're going to do here is we're then going to plug in our values. Okay, so we're going to get x equals negative, and then b here is going to be 4. Remember, anytime we substitute values, we want to make sure that we're using parentheses. Plus or minus the square root of b squared, which is 4 squared, minus 4 times 1 times negative 45. Okay? All of this over 2 times 1. Okay, we're going to start clearing this up a little bit. So we're going to get x equals negative times 4 is negative 4, plus or minus the square root of 4 squared is 16, minus 4 times 1 is 4, times a negative 45. 4 times 45. Well, 45 times 2 is 90. And the 90 times another 2 is 180. So this will be a plus 180. All of this over 2. Okay. We can clean this up a little bit more. We'll have x equals negative 4 plus or minus the square root. 16 plus 180, okay, would be 196 over, oops, that's a little too far, the over. Let's clean that up a little bit. Over 2. So we get x equals negative 4 plus or minus, now the square root of 196. Okay, so we can kind of think about that a little bit. I know you guys will have the calculator for the exam, but I want to make sure that we are able to do this as well. So we do know that 12 times 12 typically is an easy one to remember. We know that's 144. You can go on from there, but hint, hint, the square root of 196 is 14 over 2. Okay, we can then clean this up and say that x is equal, okay, and we have two different parts here. We have the plus and the minus. So we're going to have negative 4 plus 14 over 2. And then we'd also have negative 4 minus 14 over 2. So my answers here would be negative 4 plus 14 is 10. 10 divided by 2 is 5. This is one answer. My other answer here, negative 4 minus 14, okay, is a negative 18, and divide that by 2 is going to be negative 9. So these are our two answers, 5 and negative 9. You need to remember that with quadratic formula, when we're solving for this, typically you're going to get two answers. You may get one answer, but it'll repeat. If you get no answers, it's typically going to mean that you have some type of imaginary number. But for your practice questions, you should be getting two values. Let's look at this next one here. Don't let this one fool you. I know a lot of students in the past say, oh no, we have different values here. Be very, very careful. Okay, your A value here is 5. B here is negative 10. And C is going to be a positive 10. Okay, so when you set this up, okay, you're going to get X equals negative B plus or minus the square root of B squared minus 4AC all over 2A. And then you'll have X equals negative 10, be very careful, plus or minus the square root of negative 10 squared minus 4 times A is 5 times C is 10. Oh, look what's going to happen here. We divide all of this by 2. Yes, and then we should have a 5 up here as well. 2 times 5. Sorry. I'm already dropping values here. So we need to be very, very careful here, because what's going to end up happening, we'll have X equals negative times negative is a positive 10, plus or minus the square root. Negative 10 squared is 100. And then we're going to have negative 4 times 5 is 20, negative 20. Negative 20 times 10 is negative 200. All of this over 2 times 5 is 10. So check it out. This is slightly different than the other one. Same steps, but you're going to see a little issue here. We're going to have X equals 10 plus or minus 100 minus 200 is the square root of negative 100 over 10. And here's the issue, guys. Here's the issue. When you put this into the calculator, if you try to take the square root of negative 100, you're going to get an error. And you'll recall we get an error because you cannot take square roots of negative numbers. You can take the square root of the positive version, and just remember that you're going to end up getting some type of imaginary number. So when we clean this up, we're going to end up getting X equals 10 plus or minus the square root of 100 would be 10. But because it's a negative, it's going to be a 10i over 10. Now, this is a complex number. Okay? Because this is a complex number, we can't combine the 10 plus or minus the 10i. It's like having a variable. You just can't, with a constant number, you just can't add them together. So we need to be very careful with that here. We can, however, clean this up a little bit, because all numbers are being divided by 10 here. So we can actually say that X equals, well, 10 divided by 10 is 1, plus or minus 10i over 10 is 1i. And this would be your answer here. If during instruction you have any questions about what's happening with the i's and how we got that, please don't hesitate to ask. I'll be more than happy to help. And then lastly, same idea, you want to set up your A, your B, and your C. You may get real numbers, you may get imaginary numbers. Regardless, you have seen both today, and you've seen them both in the past. Okay, if you need any help, please let me know. Another quadratic formula question here. I know this is a lot of them, but it's really, really good practice. Again, you may get real numbers, you may get imaginary. It is important to do this and see what happens. All right, so let's go ahead and solve this product here. So what we have here is we are multiplying two complex numbers. You'll recall multiplying complex numbers is just like multiplying binomials, okay? To where we're going to have to set up and use the box method. Okay, so I'm going to set up this box method here. we're going to have 1 plus 5i times 4 minus 2i. When we multiply this out, 1 times 4 is 4. 1 times negative 2i is negative 2i. 5i times 4 is 20i. And 5i times negative 2i is going to be a negative 10i squared. Okay, we do know and see that we should be able to combine these terms. We'll do that together in just a bit. But let's go ahead and start pulling all these terms out. We're going to have 4 minus 2i plus 20i minus 10i squared. You guys see here that we can combine these like terms. So we'd have 4 plus 18i, because negative 2i plus 20i is 18i, minus 10i squared. Now we're not done here. You need to remember, and it's important to recall, that I squared is very significant. Okay, I squared is equal to negative 1. This is because when we saw this in the past, we found out that I was equal to the square root of negative 1. But knowing that I squared is negative 1, this changes the setup to where we're going to end up having 4 plus 18i minus 10 times a negative 1. So when we clean this up, we'd have 4 plus 18i. Negative 10 times negative 1 would be a plus 10. We can combine like terms. 4 plus 10 is 14 plus 18i. And we're done. So again, this takes older skills of multiplying binomials, which we've done in the past, with newer skills of identifying complex numbers and working with these squares. Okay, let's go ahead and move on. This is going to be your practice problem. Same steps, same ideas. Hint, hint, these values are actually conjugates of each other. We might actually have more values clear up when we combine like terms, but all the same steps are going to be applied. Okay, so solution sets. This is an interesting question here. And I want to make sure that we really deep dive into this one here. They're asking us to solve for values that work for this here. So to do this is you always want to just like test numbers. Test your zeros. Okay, the first thing I want to test is x equal to 1. Why am I going to use 1? Well, 1, okay, is if I take x minus 1 and set it equal to 0, and I'm getting that from here, okay, we find that x equals 1. So if we test this out and I plug this into the equation, okay, we'd have 1 minus 1 times 1 minus 6 is greater than 0. Well, 1 minus 1 is, okay, 0. Okay, and then we'd have 1, let's see here, 1 minus, we get negative 5, greater than 0. 0 times negative 5, okay, 0 times negative 5 is 0, greater than 0. 0 is not greater than 0. This is no good. So our solution set actually cannot include the value of 1. Okay, I know this might seem a little confusing. We're going to do some more test points right now. If we use the other possible 0, if I take this x minus 6 and I set this equal to 0, we would end up solving that x equals 6, and we can test that point as well. So we could use 6 minus 1 times 6 minus 6 is greater than 0. Well, 6 minus 1 is 5, times 6 minus 6 is 0, greater than 0. 5 times 0 is 0, greater than 0. This is also not true. So we can't include these points. So it's like, okay, well, what are we going to do here? We have some solution set. We can have points maybe between 1 and 6, or they could be points outside 1 and 6. It won't be both. You'll recall when we do and graph inequalities, our lines are either going away from each other or towards each other. So let's test the value between 1 and 6. An easy value we can use is 2. If I try x equals 2, and I plug this in, I could say 2 minus 1 times 2 minus 6 greater than 0. Well, 2 minus 1 is 1. Okay, times 2 minus 6 is negative 4 greater than 0. 1 times negative 4 is negative 4 greater than 0. This is no good. None of this is good because negative 4 is not greater than 0. So what that's telling me is it cannot be a value between 1 and 6. We can try another test value. Let's try 5. Okay, if I try 5 and I put that into the equation, 5 minus 1 times 5 minus 6 greater than 0. 5 minus 1 is 4. 5 minus 6 is negative 1 greater than 0. 4 times negative 1 is negative 4 greater than 0. This is also no good. So it can't be any value between. What about values greater than or outside? So an easy value to check, let's think of a number outside of this here, like try 0. So if I try 0, x equals 0. And why am I using 0 again? It's a value smaller than 1. We're testing for values outside these boundaries. If I try 0 in here, I'm going to get 0 minus 1 times 0 minus 6 greater than 0. 0 minus 1 is negative 1 times 0 minus 6 is negative 6 greater than 0. Negative 1 times negative 6 is a positive 6, and this is true. Okay, so that means that it's got to be outside the range of 0 and 6. In other words, if I have some number line, then I have 0 and I have 6. Okay, we know that it cannot be any value between. So what I'm proving here is that right now I'm at 0. Oops, and I should change this here. This should actually be a 1, because that's our first starting point, is at 1. It's got to be some values that are less than, because 0 worked. This was a good value. Well, let's try a number larger than 6, like 7. If I try 7, okay, if x equals 7, and I put in 7 minus 1 times 7 minus 6 greater than 0. 7 minus 1 is 6 times 7 minus 6 is 1 greater than 0. 6 times 1 is 6, which is greater than 0. This works. So that means that we have some value that starts here at 6 and goes on forever. So this is our solution set. I know this was a lot of work. My recommendation for you guys, like when you do your practice right now, is just test a couple of points that are either on the inside or the outside. And this is what we're looking at here. So now if we were going to write this in set notation, okay, you would say we're coming in from negative infinity to 1. Negative infinity to 1. And we'd go from 6 to infinity. And this is our solution set. Okay, very, very important. I know this was very in-depth. This was a lengthier problem, but I'm sure you guys will be just fine. Same idea here. What I want you guys to do is test 2 and 9. Test values between 2 and 9. If those don't work, then you need to test values outside 2 and 9. Just very easily. Those are going to be your test points there. If you have any questions, please let me know. Same thing here. You want to test values between 4 and 8. Test values outside 4 and 8 as well. Okay. Here we've got quadratic regression. So last year I had to teach this using Desmos. This year we're using the Inspire. You'll recall you need to create a list and spreadsheet. Okay, list and spreadsheet. Okay, make sure you set your X, and your y, and you put in all your data points. You can't see, actually, yeah, you can see all my data points. This is good. So we have all the points in here. When we put all this in, you then need to create a quadratic regression. So when you do your calculations, this is in the calculations document, you'll recall you need to go to Menu, Stats, Stat Calculations, and this is a quadratic regression. Okay, this is a quadratic regression. So that you, in order to answer this, you need to write out your equation. Like it says here, you can write it off to the nearest thousandths. That's your third decimal place. So your A is equal to 0.248. Your B is equal to 0.756. And your C is equal to 4.03. Now, to get your equation, I know some of y'all are like, sorry, I just can't remember what the quadratic formula looks like. The calculator gives it to you. It's right here. All you need to do is plug in the values. So your answer to this is A. Well, A is 0.248 x squared plus B, well, B was 0.756 x plus C, which is 4.03. Okay, this is your equation. This is your z equal to y. Now, is this quadratic regression a good fit? To determine if it's a good fit, you need to look at your r squared. And your r squared needs to be close to 1. So when you answer this, it's like, okay, well, r squared equals 0.999. 0.999 is like getting a 99 on a test. This is really good. So you're going to say 0.99, which is close to 1, making this a good fit. Okay. Just as a reminder, anything better than a 0.8 would be a good fit for you guys. So this is all on the calculator. There's really no calculations that you need to do other than following these steps. So again, you want to put your data points into a list and spreadsheet, create a new document. You're going to go to Menu, Stats, Stat Calculations, and run a quadratic regression. Be very careful. Some of you guys are in Quartic. You need to read it. It's quadratic. We will never use Quartic. Okay, this is your problem set. You're going to plug in everything here. You should be able to get an equation and tell me if this is a good fit based off your r squared value. All right, so here we're going to have a question on, this is something that I did not really cover too much in class. We did do vertical axis of symmetry with these parabolas, but we primarily focused on vertical parabolas, not these horizontal parabolas. I don't know if this is going to be tested. I just want to make sure that we are set to go on this. Just a reminder, when we did do this, the same rules apply. We have 3 different values, the equation, I'm sorry, not the equation, we have the focus, the directrix, and we also have the vertex. And you'll recall that the vertex is always going to be between. So if we have some type of focus, the vertex, and the directrix, the vertex here is always the middle. Always in the middle. Okay? And here's your directrix and your focus. Okay? And then p-values, p are going to be within the equations. I know this seems like a lot. If you see this question, if this question comes up on the exam and you miss it, I'm not going to be all that upset. This is not a very common practice, even in the college curriculum. Okay, but I do need to get you all ready for it. So let's go ahead and do a practice problem here. What I'd like to have you guys do is graph this. The directrix says x is equal to -3. Well, this would be some type of vertical line here at x equals -3. Okay. Your focus is at 5, 3. So we come up to 5, 3, which would be here. Oops, nope. Too high. Okay, we'd be at 5, 3. And you'll recall that focus is at that point like inside the parabola. And your vertex would be at 1, 3. So we'll go to 1, 3. And essentially that just means that our parabola looks like this. Okay. I know something that we're not typically used to seeing, but it is what it is, and I just wish that we practice this. You'll recall that we'll have this equation here. We have x equals 1 over 4 p y squared. But we have some changes, and we have some vertical changes and horizontal changes happening here because our vertex isn't at 0, 0. This equation works perfectly if our vertex is at 0, 0. It, however, is not. You recall using our vertex of h and k, 1 and 3. So this actually changes the equation to x minus h equals 1 over 4 p times y plus k squared. And we need to use our h and our k. So when we do that, it ends up being x minus 1 equals 1 over 4. Well, hold on. What is p, right? It's asking for p as well. So I'm going to pause here. P, and let me change colors. P is going to be the distance between, okay, your focus and vertex. So how far is it between here and here? Well, that's going to be 4 units. So P here is equal to 4. From 1 to 5 is 4. So we'd have a 4 here times y plus k squared. Oops, and I'm sorry, it's not y plus k, because we know what k is. K is 3. And so essentially our equation is done, right? Like this is it. We have all of our values, but you may be asked to solve this like as y equals. So we want to isolate y, okay? So to do this, we just kind of clean this up a little bit. We'd have x plus 1 equals 1 over 16 times y plus 3 squared. So I want y by itself, so the first thing I need to do is I'm going to multiply both sides by 16. The reason I'm doing this, I want to get rid of that 16 there in the denominator. Okay, so let me clean this up here. So we're going to get 16 times x plus 1 equals y plus 3 squared. I want y by itself, so I got to get rid of this squared. The opposite operation of a square is a square root. These simplify out. So we get square root of 16 times x plus 1 equals y plus 3. This square root of 16 times x plus 1, we actually can split that up as the square root of 16 times the square root of x plus 1 equals y plus 3. This is all just for proper math notations. Okay, square root of 16 is going to be plus or minus 4. Square root of x plus 1 equals y plus 3. Almost have y by itself. We now need to subtract 3 from both sides to simplify out. So we get y is equal to plus or minus 4 square root of x plus 1 minus 3. Yikes. Okay. Crazy. This is a lot of work. again, this is a timed test. You might not have all the time to do all this work. So what's going to be important to see, and I want you guys to look at this right now, is this equation, in other words, is y equals plus or minus, okay, our some value here. I want to say it's 4. Yeah, it's actually going to be the square root of 4 times b, but don't worry about that. What I want you to see here is you're going to have some value, square root of x, okay, minus, okay, well, we would actually have our h value here, should be plus our h value, and then minus your k value, kind of like the opposite. Check this out. I know that's kind of like an arbitrary way of looking at this, but I think it would be helpful on the practice problems. And then this is your practice problem. I know this is going to take some time. So you have all period to work on this. If you didn't finish it, you need to finish this at home. I will be more than happy to help you guys out with this on Friday, because I know this was yikes. Okay. Thank you guys. I know this is one of our longer videos, but y'all are amazing. You're fantastic. Have a great rest of the day. Be great, and we'll finish this up, guys. Have a good day.